Welcome to today's webinar, Big Monitoring Fabric Customer Case Studies. My name is Judy Ash, and I'm the Head of Corporate Marketing at Big Switch, and I'll be your host for today's webinar. We'll talk about stories from 5 key customer deployments, all of which are in production today, and we're excited to share the information we have about these particular customers. Let me introduce Praful Baidasna, Director of Product Management for Big Monitoring Fabric, and Syed Gair, our Director of Systems Engineering worldwide. As we go through the presentation today, feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this video in rebroadcast or on demand and have questions on a particular upcoming topic that you'd like to ask our panelists, please just go to bigswitch.com/webinars and submit a question using the link provided. We've also provided you with handouts for today's session. You can download them directly from the Handouts tab on your dashboard. Let me take this opportunity then to introduce Praful, our Director of Product Management here at Big Switch.
Good morning and hello everybody. So today we are going to have a very interesting agenda. We are going to not just talk about the Big Monitoring Fabric features, which we have talked about in many different webinars prior, but today we are going to focus on the customers' case studies which show how Big Monitoring Fabric has been deployed by customers and the value props that they have seen while they were deploying the Big Monitoring Fabric. So we are going to focus on the 5 case studies: Extranet Security Tool Chaining, Visibility as a Service, Science DMZ, East-West Traffic Monitoring, and Remote Monitoring. So to make sure that everybody is on the same page, let's do a quick overview of the Big Monitoring Fabric product. Big Switch's vision is to deliver hyperscale style networking or monitoring to any data center. And what's interesting here is that the hyperscale companies like Google, Facebook, and Microsoft actually just want to work on their own business. However, they feel that networking is in their way of doing the business. And they've experienced this in such a big way that they have led the way in showing how networking or monitoring can be made to work for the business. They came out with their own architecture for networking. What they want is simplified and automated networking/monitoring rather than using traditional complex box-by-box managed NPPs. They want to be able to centrally manage all of it in an architecture that can scale as well as have dramatic cost benefits as opposed to proprietary and expensive network backup brokers. To achieve these goals, they realized that they would need to use open networking switch hardware. They would need SDN, software-defined networking, to manage the topologies, and finally build modern data center architectures that could leverage and provide the simplicity, agility, and the cost benefit they desire. Now the question here is, how can enterprises follow this lead which the hyperscale companies have been providing? And the way they can follow this lead is by using Big Switch. What Big Switch does here is deliver production-grade solutions for enterprises based on the same tenets used by the hyperscale companies. At Big Switch, we provide future-proof SDN controller software that runs on the open vendor switch hardware to build Big Monitoring Fabric, which is the next generation network packet broker. Now, if you look at this diagram, on the left-hand side, you have a production network. In the center, you have the Big Monitoring fabric of switches. And on the right-hand side, you have the centralized tool farm. Now, the fabric that's sitting in the middle, the Big Monitoring Fabric, can be built from as small as a single switch or many switches. But the key part here is once you've connected the switches, once you've built this topology, the entire fabric can be discovered by the 2 controllers sitting right on top. These controllers act as a single centralized pane of glass. In fact, if any one of the links go down, then the controller automatically finds redundant paths so that your packet flow from your production network to your centralized tool farm remains uninterrupted. With this topology, you are now able to secure, monitor, tap every rack or every virtual machine, irrespective of the topology, irrespective of the vendor, and send it to any or all of your tools. Given the fabric is a scale-out fabric, that means that if you feel that you need more bandwidth for the fabric, you can just keep adding switches. However, since the entire fabric acts as a logical single big switch managed by the controllers, which is incidentally how the name of the company came about, you can grow without having to buy new expensive network packet brokers as your production network increases. Now, when we came out with this architecture, customers came back to us and said, oh, but we've already invested in expensive legacy network packet brokers. While we like your architecture, what can I do so that I can repurpose them? And the answer was pretty straightforward. You could actually use your NPVs, in fact, even more efficiently by connecting them to your service ports. With this, you're making more efficient use of your existing NPVs as well as protecting your investment on them. However, if you want advanced functions like regex, matching, deduplication, slicing, header stripping, netflow generation, we also have an x86-based appliance, which is what we call the Big Mon service node, which actually plugs in right into the fabric and will be managed by the same single pane of glass, the Big Mon fabric controller. So with the Big Mon service node, you get the x86-based appliance running DPDK code to provide you excellent performance and at a very competitive price point. Now, so far we've been talking about out of band. With Big Mon Fabric, you can actually even go inline. You can take the same switches, the same open vendor hardware switches, which could be Dell, Acton, Quanta switches, and put them inline. And in fact, have security tools chained across to provide visibility or security functions in line within your DMZ or your extranet environments. You can also create an ACL-based span to take certain traffic out of your production network and send them to an out-of-band tool for historical analysis if you so desire. But the key point here is your inline as well as your out-of-band is again managed by the same single pane of glass, which is your Big Mon fabric controller. Now, if you look at the topology I've shown you right now, and if you want to scale that down a little bit, exclude the controllers, exclude the tool farm, and that scaled down version, you can actually go ahead and put it at all your remote sites. And now you can see that all of your remote sites, your main sites, your inline, are managed by the same Big Mon fabric. The remote sites can use L2GRE to get the data from your remote sites to the main Big Mon fabric in your main data center and then send it to the centralized tool farm. You do not need to have tools at various different locations. All of this makes your operations very simple, keeps your costs down, and gives you the single point of visibility and management, not only just for creation of your fabric, but also for troubleshooting, also for orchestration, also for error handling. Now, if you compare this architecture with a traditional legacy network packet broker architecture, let's see how we compare with that. Behind the scenes of a network packet broker architecture, which is legacy, you would have a couple of supervisor cards, you would have line cards, service cards, and a backplane. Now, with Big Mon fabric, the supervisors become the Big Mon fabric controllers. The backplane become the core or the spine switches of the fabric. The line cards are basically ports which connect to your production tap and span ports, and some line cards would be connecting to your centralized tool farm. And the service cards are essentially the ports which are connecting to your Big Mon or third-party service nodes. So as you can see, the Big Monitoring Fabric is essentially very similar to a traditional legacy network packet broker architecture. However, there are two key benefits of the Big Monitoring Fabric architecture, which is why we call it the next gen or the future-proof architecture. The first advantage is that on the left-hand side in your legacy network packet broker architecture, your backplane was fixed. Once you've utilized all the bandwidth of your backplane, you would have to buy another chassis. Well, not so with the Big Monitoring Fabric. If your bandwidth has been completely utilized, you add more spine switches, you add more leaf switches, and you can extend your fabric, still maintaining the single pane of glass management. And the second point is, if the supervisor cards, one or both of them on the legacy network packet broker went down, you lose half or all of your bandwidth, your box's host. If you contrast that with the Big Monitoring Fabric architecture, if one controller goes down, the fabric still operates as if nothing happened. If both the controllers go down, the fabric still operates as if nothing happened. The reason is the data path through which the packets flow through do not need the controller to be present. This shows that the Big Monitoring Fabric has a higher level of resiliency than traditional network packet brokers, while still providing much more value at a much more economical price. So what's the value prop for Big Monitoring Fabric? 3 easy words. It's simple. We make things simple. We help monitoring scale out, and we are economical. So using a software-defined networking architecture, using our open network switches, leveraging the open network switches that we use in our fabric, we basically are able to provide simplicity, scalability at very, very dramatic economic benefits to our customer. Now, looking at the feature comparisons, as you can see, we are very, very comparable with legacy network packet brokers with respect to features. In fact, we also have features which they don't have. For example, we can build a scale-out multi-tier fabric. The Big Monitoring Fabric has been designed with the fabric in mind. It's not a box-by-box based architecture which people are now trying to retrofit to make it into a fabric. We can leverage existing network packet brokers by service node chaining them. And we also have the ability to do packet captures, which is very good to have, especially when you want to debug something. And let's say your tool, the person who's looking at the tool is saying that he's not receiving any flows, and he blames the network, obviously. And you can quickly enable the inbuilt packet capture feature that we have on a controller, and you can quickly verify whether the policy is fine and if the problem is on its tool end. Additionally, given our focus towards simplified operations, we have helper functions. For example, host tracking or device tracking or DNS or DHCP tracking, which basically provide you more information about your production network with zero impact to the production network. All of this is possible because we have the SDN controlled, SDN managed architecture by which all packets can be sent to the controller when required for such helper function use. We've been winning a lot with our customers irrespective of the competition. And here are the 4 main use cases where we see where Big Mon Fabric has a very, very good traction with our customers. The first one is pervasive security and visibility. We help customers monitor or secure every rack, every VM in their organization. Prior to Big Monitoring Fabric, a lot of customers, when I talked with them, had common complaint, which was that they would have to compromise on their monitoring needs because the network packet broker was way too expensive. with our ability to scale out, with our ability to enable the customer use a pay-as-you-grow model, with our ability to use open vendor switch hardware, which basically brings down the costs, pervasive security and visibility is no longer a pipe dream for our customer. The second use case, DMZ and extranet security. This also has a sub-use case for Science DMZ, which we will talk about a little bit later. But given the way we have our GUI, which is basically providing a lot of simplicity, we have a lot of drag and drop for you to be able to create, build, or even bypass security chains with the click of a mouse. That makes it so intuitive for our customers to be able to do scale out security tool chaining, which none of our competitors currently are able to do. All of this at great economics. In the mobile and LTE monitoring world, the customers really love the way we can scale, get all the data, which they can forward it to the tools so that they can ensure that the SLA for the voice traffic is being met, and if there are any issues, they have the ability to quickly detect and then resolve whatever issues that are there so that the customers do not see any degradation in the service. And finally, we have a remote monitoring use case by which, as I showed earlier, you are now able to not only monitor your main data center, but also add remote sites or branches or locations that the organization may have, and still have a single pane of glass visibility for all your monitoring visibility / security needs. This actually was a validation which is there on the web. It is a public validation by Intuit, where they talk about why they went with the white box solution and Big Monitoring Fabric to be able to monitor more, secure more, and be able to actually use it through the peak of tax year 2014. They were earlier trying our competitor network packet broker, and they found that it was not scaling and it was getting too expensive for them to be able to get the monitoring comprehensiveness that they wanted. And then we have another customer who basically is using us inline, and they selected us because we were easy to deploy as well as operate. We had a lot of scalability benefits, and we had an excellent feature sets even with our GUI. And now I'll hand over to Syed, who's going to provide a lot more content and information with regards to the customer case studies that we have now.
Thanks, Praful. Today we are going to go through like 5 case studies. The first one is around inserting security tools in your extranet environment. So in this case, the organization had a mandate on deploying advanced security services at their extranet DMZ sites. So they started by first evaluating their production devices which they already have in the network, and how they can insert these services leveraging existing features like doing VLAN bridging or doing PBRs, policy-based routing, and inserting these appliances. But essentially, when they looked at all the things which go around deploying these services regarding high availability, bringing the resiliency, and adding more, once starting from one service going to 2, 3 services, adding all those services in chain, that was becoming very complex. So they went ahead and started to explore all these inline technologies which are out there. Multiple vendors were giving these offering these platforms to insert these services, and once they started exploring those technologies, one of their key requirement was having sharing these extranet links to the services. Essentially, you can have multiple extranet links coming in from firewall, and you need to share those to the same security service. So that was one of the key requirements, and we were the only vendor which was providing that requirement that time.
I have a question. So a lot of our customers say that Big Monitoring Fabric, and rightly so, provides a lot of simplicity, it provides a lot of scale out, and at the same time it is providing a lot of cost benefits. Was there anything else so special about Big Monitoring Fabric that this customer liked?
So key element was around feature velocity, because at the time when they came up with their requirements, we were not offering sharing the tools across multiple extranet links. So they were able, they put that requirement up there. We delivered the feature within 2 months. They were able to go into POC with the same feature and moving towards production pilot. And the thing which was most impressive was around the quality of the solution itself. Even though we were delivering the feature so fast, but we were maintaining the quality of the code at the same time. Plus, they were also looking for advanced features around having health check, making sure that the services are available, and if the service goes down, how fast you can converge to the services on the other side to bring the resiliency. So all that capability was there with Big Monitoring Fabric inline solution. Okay, moving on to case study number 2, where in this particular case, that was a large enterprise. Their vision was to have monitor each and every link in the network, pretty much going from DMZ core to their data centers. They wanted to monitor everything. So it was around thousands of tabs they were connecting. And the challenge is that they started with the traditional network packet brokers. And when they started this project, this became so complex just to deploy and manage the devices that the project stopped up in phase 2. They took a step back and looked at how we can do this differently so that they can scale and maintain and make it more usable. So finally, they selected Big 6 solution because of the centralized control plane, so that they can scale out and they can tap at more places, but at the same time, they have the centralized controller to manage all their policies. One of the key requirements which this customer had was providing these visibilities as a service to different business units. So they can have a security business unit, they can have an ops business unit. So one of the key requirement around giving this visibility as a service was providing rollback access control, which means that if one business unit log into the fabric, they can go ahead and build their own policies, but they don't have visibility into any other security tool or any other tool. They only are restricted to see the tools which they own. So in this piece, the key element was that if you deploy and if you're looking for having a visibility into network A, and if the security team logs in and they are also looking at the same network and looking at the same tab, we should be able to provide that solution. So with one of the features which we had in the solution called overlapping policies, we were able to deliver the solution such that if user 1 comes in, enforce the policies, and then start looking at network A, and the user 2 comes in, and if he wants to look at the same traffic on the same filter ports, we can go ahead and create a dynamic policy such that we can deliver the traffic to the two tools simultaneously.
I had a question here too, Sid. So you are well aware that we call ourselves the next generation architecture for network packet broker, and one of the reasons why we do that, it's not the only reason, but one of the reasons is because we have the REST API first principle based architecture. So when you look at other solutions, they would have built their feature set over the years. Now they start to add REST API as a separate feature for certain of the functions. But given that we do it as a REST API first, all our interactions, whether it's a CLI or whether it's the GUI for the controller, all of them internally use the REST API. Was this architecture useful for this customer in making a decision?
Yeah, interestingly, the answer is yes, because they were not looking at our GUI to deploy the policies, and they had their existing custom portal which they want to leverage so that they can provide that portal to all the business units. So every business unit can go and log in. And as you mentioned around the REST, so every feature we build here in this product, we build REST first, and then the CLI and GUI becomes the client for the REST. Similarly, their portal also became the client for the REST. And essentially, they were able to have this scalable solution by integrating with the controller first, and then as you add more ports, filter ports or delivery ports, it's just you are scaling out the fabric, but the effort of your integrating with the controller remains the same. Cool. Moving on to case study number 3, where it is again around Big Monitoring Fabric inline. Here, this is on the customer. It's Science DMZ use case, which is more relevant to universities, where they have these 100 gig links coming into the network, and in their case, there were these the traffic was going through the firewalls, and they were also inserting various advanced security services as well. But the challenge was there were large flows, elephant flows, which were going through these services, and these services were potentially getting slowed down, or in some cases were also going offline or crashing because of these large flows which are going through these services. So the requirement was slightly different for this particular use case instead of the first use case which we discussed. In this case, we had to define the interesting traffic to bypass the service. So typically you go ahead and define interesting traffic that, okay, this is the traffic of interest, and redirect this traffic to a particular service. But in this case, we have to select the traffic, but then we say, okay, for this particular traffic, which was the elephant flow traffic, redirect, instead of redirecting, just pass through, because the traffic is already trusted, so you do not have to make this traffic go through various services. If you look at it right now, typically the traffic, which is the interested traffic, will go through all the services before heading to the trusted zone. In this particular case, we were also leveraging the REST APIs, where the traffic was going to an analyzer Globus, and in the Globus, where they were analyzing the traffic, and if they see any elephant flow, they were able to trigger a notification to Splunk, and the Splunk, looking at a certain tagged notifications coming from Globus, they were able to initiate the REST calls on our API, via our API. And with this REST call, they were updating the policies. And in the policies, what we are saying that, okay, for this particular match rule, bypass the firewall. So you can see in the updated policies, the traffic is no longer going through the firewall. It is only going through another service.
Thanks, Sayed. So the Science DMZ use case, as I understand it, is catered towards 100 gig flows coming in, sharing of science data, and given that it's an elephant flow, it gets pinned to a particular core of a firewall, of a firewall, and that can actually affect the performance of the firewall, even cause it to go down. And the only way to avoid this is to bypass it for those trusted elephant flows. Well, it makes sense for the universities to do that. Do you see a similar use case for enterprises as such, which could make use of such a feature?
Yeah, definitely. On things like you can have similar elephant flows or large flows coming from storage traffic as well, where you can doing remote backups, but this is a trusted traffic. You know about this traffic, and now you can go ahead and bypass the traffic based on the policies.
Very good.
Cool.
Yeah.
Now moving on to case study number 4, which was on monitoring every rack. Essentially, in this case, the customer was planning to deploy a new data center. They had some experience with existing network packet broker technologies, and they were deploying those in their existing data centers, and they knew the limitations based on the way they were troubleshooting or doing network performance today by connecting the tools and the filter ports or tap or span ports together on the same box, and that was just not scalable. And when they were moving to the new data center and the mandate was to monitor every rack, they looked at the technology which can scale better. And with our 3-tier architecture, they were able to achieve that. And not only they looked at our fabric as a next generation fabric, that also helped them in selecting the tools. So instead of going and buying some tools which go and connect to individual network packet brokers, they were looking at more like, okay, how much bandwidth this particular fabric can provide, and how much traffic that it can go and collect and deliver it to the tools. Based on that, their tool decisions were different as well.
So I've been analyzing all the data that we have. I've come to realize that whenever we are with a POC, we typically always win the POC irrespective of who the competitor is. And secondly, once the customer buys into our product, they always come back and buy more. They are so happy with the product. Is there anything that we see with this customer, given that he's also been a customer for quite some time? What are the next steps for him?
So they initially rolled out into 2 data centers. Now they are looking at rolling it out on their 3rd data center. And also right now we are actively doing a POC around our inline technologies, because they at their extranet and DMZ side, they want to insert advanced security solutions. So now security team is seriously looking at us.
Okay, very good.
Moving on. Now the last case study is around remote monitoring. Here you have the same concept. We have the fabric and you are monitoring the existing data center, but in this particular case, the customer had remote data centers in various locations within the United States, and they wanted to not put tools in each and every data center, and there were some advanced on-demand troubleshooting, which was one of the key requirements. And what they wanted to do was simply extend our own fabric by using our L2 GRE technology and extend it to the remote data centers. And once they deployed it in US, now they are moving into Europe and Asia as well. So essentially, in US, they have one primary data center and multiple remote data centers. And also similarly in Europe as well, they are designating one as primary data center where they have all the tools, and then they have the remote locations where they are tapping the traffic and bringing it all the way to the primary data center.
That's great, Seth. So while we have a lot of our customers implement various use cases that we've already discussed about, it's good to know that this customer is taking on the remote monitoring and really applying it to his organization worldwide. So for this customer, what do you think are the next steps?
So one of the way they are looking at bringing the traffic into the centralized data center, so this could be potentially the SSL traffic. And for their tools, they are only looking at the header instead of payload. But the payload is also getting encapsulated and being sent over the links, the production links. So the way they want to utilize our service node by doing the stripping technology, like, okay, you turn on and you only strip the payload and only send the header information back to the tool, because the tool should not be overloaded with the payload, as well as you are not essentially impacting the bandwidth of the production network.
Okay, very good. So they are now looking at Big Mon service nodes to
for the remote data centers.
Perfect.
And with that, over to you, Judy.
Thank you both. Syed and Praful, these are great stories, and it is really good to hear what our customers are doing in their production deployments, things we can use and share with other enterprises who are considering the same path. If we discuss something that piqued your interest today and you would like to know more, just head over to our website, bigswitch.com, or you can send us an email directly at info@bigswitch.com. We make it really easy for you to get started with our solutions and offer 3 choices that are pretty popular. Big Switch Labs, perhaps the most easy to access, is in a way for you to experience Big Switch Network's bare metal solutions firsthand from the comfort of your laptop. There's no better way to learn about a product than to actually take a test drive. So for a free online and real-time access to our SDN Fabric products, please visit labs.bigswitch.com, and you can download the handout that's in the handout section of the webinar. Secondly, in January, we launched free Community Edition solutions, where you can actually download both our production-grade Big Monitoring Fabric and Big Cloud Fabric solutions. You'll find more details on these. There's a handout in the dashboard and also online. And finally, and certainly not least, we have launched starter kits for both Big Mon and Big Cloud Fabric. Starting at a list price of $29,000 or $39,000 respectively. These kits include everything that you need: switching hardware, software, cables, support, and we make it very easy for you to implement your very first SDN-style data center pod. And if you need more information on that, there's a detailed brochure online, and of course you can always look and reference www.bigswitch.com. Please keep your eye out for an email invitation to our next event. We are online again next week on Thursday, August 18th at 11 a.m. Pacific time with Broadcom and Big Switch. Open networking is fast becoming a reality. Are you ready? This one will be hosted by our own Rob Sherwood, and we look forward to telling you more about it. Watch for emails on registration, and with that, we conclude our presentation for today. We appreciate your time, and again, welcome your feedback. Thank you, and have a great day.